And then land cost, even though it has quadrupled in certain U.S. jurisdictions, it's just not that significant compared to the the core and shell and the mechanical electrical plant. So everything's gone higher in terms of just the piece parts, but you do get scale advantages to building a 2 gigawatt site versus a 200 megawatt site, and so that's been kind of an equalizing factor.
And in terms of the numbers, so I think most people around the world will use the old $10 million a megawatt number when talking about a facility generally for cloud or even a wholesale style facility. The numbers that we're seeing for AI, I think specifically for training, they seem to be significantly lower, or is that myself and Reese misreading press releases?
So let's just say here in Asia, you got bookends like India. India might be mid single digit million per megawatt, and then Japan might be 18 million, and then in between would be kind of that 10 to 12 million US per megawatt, maybe in the States now, if you're just putting together a business plan from scratch, the number might be 12 million.
Even for AI?
So for AI, if it's going to be liquid cooled and you're going to use direct-to-chip liquid cooling, you might add another million per megawatt, or maybe another kind of roughly 10% on top of it. So the direct-to-chip liquid cooling, which is sort of an add-on. So a cloud data center that has a chilled water loop, not to get too technical, you could quote unquote AI-ify it and do direct to chip even after the fact by adding CDUs and kind of that secondary loop, and that it's been done, and it adds maybe a million on top of that.
But I suppose this is where we see a number of neoclouds whose background is in crypto mining, because the facility requirements weren't that different. It was large amounts of cooling at scale, probably somewhere remote and shady. And that's for different reasons in this case. But it seems to be that's so there's that transition. But then, and in those cases, the cost, when we budget it, we're talking core and shell plus operations is our sort of CapEx. But now the number is shifted up to the chips. So that bit's a bit cheaper, but it's still, you're spending a lot per.
Yeah, I mean, $100 million data center fully fit out, the kit inside might be 400, 500 million, because that's just how expensive the GPUs are. Whereas in a cloud data center, you didn't have that kind of mismatch between the equipment inside, the racks versus the base building. They were more equal. Now there's like a massive disadvantage. Or a massive mismatch. But the pivot from crypto data centers into AI data centers, I think part of that is just around value creation. So crypto companies might be valued by the market at 4 or 5 times EBITDA, whereas data center operators get valued at, say, 20 times EBITDA. Or higher. So it's prudent, if you have access to power, which both crypto needs as well as AI, the highest and best use of that, at least as valued by the market, is to create more of an AI data center business than purely a crypto business. So I think that kind of explains the pivot that we've seen. Plus, there's just so much demand for data center capacity, and these companies that have been doing Bitcoin mining for a while, that certainly is a comparative advantage that they have, because they've been in these remote areas for quite some time. Now they're still learning how to build a different type of data center that might be more expensive, but the energy piece, which is kind of one of the major pinch points towards creating AI capacity, that's something that they have. It's less of a constraint for them.
Yeah, I suppose if you see some of the pitch decks floating around the Middle East of sites, if you look at the same site over the last 5-10 years, it might have been pitched as a potential refinery of some sorts, then moving into being a crypto mining site, and then being into AI. But the core and shell is still, we've got lots of power generation coming into a building. We're just trying to find as you say, maximal value use case for for that block. Where does that leave the risk then? So, if we're now, you've got your core and shell, you've got your operations, then you've got your chips, and whether or not that's directly owned by the end user, the chips are the most expensive part in an AI data center as it stands. And they also have the fastest refresh rate. So is that also the most profitable part to be involved in? Or, because we often view things through the lens of the data center part, which is the building and the operations.
If you're getting monthly recurring rent by renting capacity, measured usually in megawatts to an off-taker, like a hyperscaler or a neocloud, and as long as the customer pays their rent, you're going to get a certain return over multiple years, and investors value that at roughly 20 times. Profitability on the equipment side is very, very different, and it's kind of beyond my area of expertise to focus on the semiconductor value chain. But clearly, you've seen, just based on the stock prices of some of these semiconductor companies, that there's massive value attached to being able to have access to the components that make GPUs.
I wasn't even thinking from the semiconductor, more from the NeoCloud layer of the business. So I don't know how, because they're not charging rent. I guess they're selling tokens.
Yeah. So the NeoCloud model is basically, some of them do build their own data centers, but a lot of them are renting space from third-party operators. So they're more of a capital light model, at least when it comes to the data center infrastructure. But then they have to finance the GPUs, and maybe they're getting companies like NVIDIA to literally invest in them to help them do so, or there's GPU financing options out there. And then their challenge is that if these GPUs last, let's say, 5 or 6 years, they want to make sure that they're charging high enough for GPU rental to recover their cost within the lifespan of a chip.
And the lifespan of a chip, like I think you touched on it in the first 10 or so minutes, but does it just wear out? Technology obsolescence? Like, what does the end of a chip life actually look like?
So it could be both, but physically it is finite. I mean, we've seen this with cloud, with CPUs, is that they do wear out. Depends on the environment in which they operate, the temperature, how many read-write cycles, depending on what the CPU is being used for. But and so it's not. There's no expiry date that applies to every chip. It's kind of statistical. So there'll be a mean time to failure. Let's call it 5 years. Some will last 8 years. Some will last 3. So it's all kind of statistical. And since cloud is kind of a shared resource, the customer never really notices it. It's incumbent on the cloud provider just to make sure they've got that capacity, because you're not literally renting each chip. You're just renting this collective pool of assets. It's the same with AI tokens as well.
In terms of moving back onto the chips, and we might be getting hypothetical here, but maybe our audience will like hypothetical. Someone used the analogy of iPhone with me previously. So when the first iPhone came out, it was a significant jump forward. And probably as they've progressed up to, what are we on now, 17, 16?
Yeah, 17 Pro Plus Max Giga, I think, or something.
Yeah, the increments, or like the performance differences, have probably been smaller than with each of the earlier models. Is that likely what we're going to see with the chips? Because there's nothing stopping me from using a 15 and probably having more or less the same experience as someone with a 19 plus giga extra large double screen 3-camera edition.
I think there's a race, where NVIDIA has a clear leadership position in terms of capability and scale, and they're continuing to innovate and create new generations so they can outdo themselves. But then you got AMD and Huawei, trying to close the gap. So I don't know. It's not my area of expertise, but I think the capabilities are still growing at a very, very steep rate. I don't think you're seeing minute improvements from generation to generation. I think they're still quite significant in terms of the amount of compute that you can get on that next generation of GPU.